Hello everyone, very good evening. Very good evening, people. So join the session quickly. So I'm just waiting for you all to join the session and we shall have an amazing session today. So we will be doing conditions for solvability. So yeah, join the session quickly and yes, as soon as you join the session, please text me here in the chat box so that I can know who has joined the session. Okay? Yes. And also do share the session with all your friends as well. And let me know how is your Sunday going on. All good, all good. Okay, chalo then. Let's start the session. So I hope you people will keep joining the session as we proceed. Okay, right. So yeah, today we are going to discuss the conditions for solubility and yes, I am going to give you an amazing trick of how to solve this. Okay, so you know that basically when a pair of linear equations is given to you, right? So you have three conditions, right? So let us firstly check out what are the linear equations, general form of linear equations. So pair of linear equations, general form I can write it as a1x plus b1y plus c1 equals to 0 is the first linear equation and the second linear equation is a2x plus b2y plus c2 equals to 0. Okay, so a1, a2 are x coefficients, b1, b2 are y coefficients and c1, c2 are the constants. Okay, and you very clearly know that when a linear equation is given, the graphical representation of a linear equation is a simple straight line. So if I want to draw a graphical representation of this linear equation, it would be a straight line. Okay, for example, this is a straight line. Now, if I am taking the second linear equation, you have a2x plus b2y plus c2 equals to 0, hai na? So I'm just taking the second linear equation also. So in the second linear equation, the line could be this way, which means it could be intersecting. Okay, so both the lines are intersecting at a point. Or if this is the first line, the second line could be this way. Okay, or if this is the first line, second line could be on the same first line. Okay, it is on the same first line, which means they could overlap over each other. Okay, something like this, they are overlapping on each other. Clear? So three conditions we discussed right now. So one is they can be intersecting or they can be parallel or they can be overlapping over each other, which means they are coincident. Okay, what do you call this as? These are coincident, these are parallel, and these are intersecting. Okay, so now this you know after drawing a graph, right? So you know this only when you draw a graph. And now today let's see, even without drawing a graph, how can we know whether the lines are parallel or intersecting or coincident, and we shall do questions based on it. And there were a lot many previous year questions which CBSE has given based on this particular topic. So it is very important. At the same time, it is very simple. Okay. So let's start now. So I told you this is a graphical representation and I promised to tell you a trick where you can remember this easily and solve. Right. So now let's see what's the trick and how can we do it. Now here it is. We know if a1x plus b1y plus c1 equals to 0 is a linear equation, a2x plus b2y plus c2 equals to 0 is another linear equation. And when you draw them on the graph, this is how you get three cases, and on the graph sheet, after you draw them, it will be very evident for you whether the lines are coincident, parallel or intersecting. And let me tell you, if the lines are coincident, you will have infinite solution. What is the meaning of solution? A point which satisfies the line is the solution for that line, right? So here you can see every point satisfies on this line. So I can say there are infinitely many solutions because the line can be extended infinitely. Okay. And if I come to parallel lines have no solution. Why no solution? Because here you can see parallel lines have no common point, or I can say there is no such point which satisfies both the lines together. Okay, so there is no solution. Whereas intersecting lines have how many solutions? How many points are satisfying here? So there is only one point which satisfies both the lines. So I can say it is unique point, or you can say it is unique solution. Till here is a session very clear for everyone. Yes. And if it is clear, please hit the like button and also the subscribe button so that you get the notifications of all my classes. Okay. So let's proceed now. That is when you draw the graphical representations, you are able to understand the type of lines and the number of solutions. Now, what if I say I am not giving you any graphical representation? You will have to, okay, by just looking at the equations, see whether the lines are coincident or intersecting or parallel. So how do we do this? For that, you will take the ratio of the x coefficients. I told you a1 and a2 are x coefficients, so please take the ratio of it. b1 and b2 are the y coefficients, so you take the ratio of the y coefficients as well. And c1 and c2 are the constants, so take the ratio of the constant. So if all these ratios are equal, okay, if all the ratios are equal, which means the lines are also equal, or I can say the lines are coincident. So the first case you get, okay, if all the ratios are equal, they represent coincident lines. Okay, coincident lines means one above the other, the same lines. And just now we have learned coincident lines have infinite solution. Okay, if all the ratios are equal to each other, if all the ratios are same, okay, see here. So this is with hands I'm going to explain you so that you will remember it very well. Okay, this is the trick. If all the ratios are same, okay, for example, this is one line, this is the other line, and all the ratios are same. So the lines are also overlapping over each other. The lines are also same. They are coincident lines. Clear? And each point on these lines is a solution of both the lines. Okay, so you have infinite solution. Now, suppose if I am taking the ratios again, a1 by a2, b1 by b2, c1 by c2, I am taking the ratios. And I find that only the first ratio is same and the second ratio is not same. Okay, which means only two ratios are same. Okay, what's happening here? Only two ratios are same. So, when only two ratios are same, a1 by a2 equal to b1 by b2. Only two ratios are same, so the lines are parallel. Very clear? Parallel lines. Okay, only two ratios are same, the lines are parallel. And you know, parallel lines have how many solutions? They have how many solutions? No solution, because there is no common point. Solution is a common point between the two lines. Okay, these are parallel lines, and you know, parallel lines have no solution. Now let's see the next case, a1 by a2, b1 by b2, c1 by c2. So here in this case, if a1 by a2, b1 by b2, c1 by c2, so nothing is equal. Okay, a1 by a2 is not equal to b1 by b2 is not equal to c1 by c2. Okay, nothing is equal. So the lines are very clear, intersecting lines. Is it clear? So the lines are intersecting lines, and intersecting lines have only one common point. Okay, these are intersecting lines. They have only one common point, and that common point is the solution. Okay, this is the solution, or you can say it is unique solution. So till here, is the class clear for everyone? Yes. So this is the trick. So when all the ratios are same, the lines are constant. When only two ratios are same, A1 by A2, B1 by B2, the lines are parallel. When nothing is same, none of the ratios are same, the lines are intersecting. So I hope after this trick, you will never forget the conditions for solvability, right? So you will always remember this, all the lines same, the ratios are same, only two ratios same, the lines are parallel, okay? And if lines are intersecting, then ratios are not equal, not equal, not equal. So I hope this is clear to you. Chalo. Now let's proceed to some questions. See the first question, write the number of solutions of the following pair of linear equations. I need to write the number of solutions of the following pair of linear equations. So how many linear equations are given? Yes. Everyone who joins the session, please do like the session and continue watching, and you can also respond here in the live chat. Okay. So yeah, the given linear equation is x plus 2y minus 8 is 0 and 2x plus 4y equals to 16. So from these two, if I just convert this into general form, this is already in general form. This is not in general form. So general form is plus c1 equals to 0, a1x plus b1y plus c1 equal to 0. So I have taken 16 to the other side. So here a1 will be 1, x coefficient is 1, and b1 will be 2, y coefficient is 2, and c1 is minus 8. And here a1 will be 2, x coefficient, this is b2. For the second line, we are taking it as 2. So b2 is 4 and c2 is minus 16. So after this, what we can do is just have a look now. So I'm just taking the ratio of a1 by a2, then the ratio of b1 by b2, then the ratio of c1 by c2. Okay, so ratio of a1 by a2, b1 by b2, c1 by c2. So it is 1 by 2, a1 by a2, b1 by b2 is 2 by 4, or it is also 1 by 2, and c1 by c2 is minus 8 upon 16, or that is also 1 by 2. So I got a1 by a2 is equals to b1 by b2 is equal to c1 by c2. So when all the three ratios are equal, the lines are also equal, right? They are coincident lines. And coincident lines have how many number of solutions? Infinite solution. Did you all understand this? Okay, so simple tha. Even without drawing the graph, you know whether the lines are intersecting or coincident or parallel. Clear? So next question. Find the value of k. So here you are finding how many solutions are there. Here you are going to find the value of k if it is given that these have infinitely many solutions. Firstly, infinitely many solutions means the lines have to be coincident. So if the lines are coincident, the ratios are equal. This is what you have to know. So if ratios are equal, just let us take the given equations. See, 2x plus 3y is 1. Or I can write 2x minus 3y minus 1 is 0. Okay. Sorry, plus 3y minus 1. So this is a is 2, b is 3, and c is minus 1. Okay. Now if I take the next equation, k minus 1 times x plus k plus 2 times y is equals to 3. Okay. So now here a1, a2 is the x coefficient, which is k minus 1. b2 is y coefficient, which is k plus 2. And c2 is the constant, which is 3k. Okay. So till here, I hope it is very clear for everyone. Now a1 by a2 is 2 by k minus 1 is equals to b1 by b2 is 3 by k plus 2 is equals to c1 by c2 is minus 1 by 3k. Okay. So now here they said that the lines are having infinite solution. So always remember the first condition you will check is for the first two ratios. Okay. So if they have infinite solution, which means the first two ratios should be equal. So cross multiplying 2 into k plus 2 is equals to 3 into k minus 1. Okay. So 2k plus 4 is equals to 3k minus 3. So transposing all k terms one side and constants one side. So I have 7k equal to, 1 second, 3k minus 2k is k, this one. It is k, 3k minus 2k is k, and you have 7. So k equals to 7. Okay, is the correct answer. Clear till here? Yes, let me know. So shall we proceed to the next one? For what value of k does the following pair of linear equations have infinitely many solutions? Okay, infinitely many solutions. 10x plus 5y minus k minus 5 is 0, and 20x plus 10y minus k is 0. So here infinitely many solution means again a1 by a2 is equals to b1 by b2 is equals to c1 by c. Clear? So here infinitely many solutions means the lines are coincident, so all the ratios are equal. So here a1 is x coefficient, which is 10, and ये 20. Clear है क्या बेटा? So a1 is 10, a2 is 20. Okay, so you got as 1 by 2. Now b1 by b2, b1 is 5 by b2 is 10y. So this is also 1 by 2. Okay, so a1 by a2 was equal to b1 by b2. Now let's say c1 by c2. So c1 by c2 is minus k minus 5 divided by minus k. Okay, so you need to find the value of k. You know that since all the ratios are equal, so a 1 by 2, a1 by 2, b1 by b2 is also 1 by 2. c1 by c2 is minus k minus 5 by k. Okay, so minus k, sorry. So minus minus gets cancelled. So you have 1 by 2 equal to k minus 5 by k, or I have k equal to 2k minus 10. Okay, or k is equals to 10. Okay, so the value of k I got here is 10. So I hope this question is very clear to everyone. Shall we proceed to the next one? So next question, here it is. For what value of k will the solution has no solution? No solution, where do you find? When the lines are parallel, there is no touching at all, no common point. Okay, so when the lines are parallel, what is the condition I told you? a1 by a2 equal to b1 by b2 is not equal to c1 by c2. Okay, so a1 by a2 is equal to b1 by b2, but this is not equal to c1 by c2. So here a1 by a2 is 2 by a2 is how much? 6 is equals to b1 3 by, this is, okay. So a1 by a2 is 2 by 6, b1 by b2 is 3 by k minus 2 equals to c1 by c2 should be 9 upon 3k minus 2. So here, since these two lines are directly parallel, okay, they are directly parallel, so we can directly take the question, because see, when the lines are parallel, we know a1 by a2 is equal to b1 by b2. So I'm just taking these two equations. So 2k minus 4 cross multiplying equal to 18, or I can write 2k equals to, how much is this? 14, or k equal to 7. Okay, so you found the value of k when there is no solution. No solution, first condition you will take is k. For finding k, it is a1 by a2 equal to b1 by b2 with the first ratios. See the next question. How many of you joined the session? people, once you join the session, let me know. Okay. Okay. Write the number of solutions of the following pair of linear equations. This is the next question. So how many solutions are there you have to write? I hope you will do along with me now. A1 by A2 is x1 by 2. B1 by B2 is 3 by 6. C1 by C2 is minus 4 by minus 7. So here very clearly, this is also 1 by 2. A1 by A2 and B1 by B2 are equal. C1 by C2 is not equal. So I can write A1 by A2 is equal to B1 by B2, not equal to C1 by C2. Okay. So A1 by A2 and B1 by B2 both are equal. C1 by C2 is not equal. So now, so therefore, these are parallel lines. So when they are parallel lines, how many solutions will you find here? Parallel lines, how many solutions in parallel lines? Definitely only one solution in parallel line you will find. Right? Parallel lines have only one solution. Clear till here? Okay. चलो next question करेंगे. Here it is. Write the value of k for which the system of linear equations 3x plus ky is 0 and 2x minus y is 0 has unique solution. Okay. So I would like you all to do this question as a homework actually. Okay. So ये homework करोगे लेकिन I'll explain you how to do this. So ये देखो, write the value of k for which the system of linear equations 3x plus ky is 0 and 2x minus y is 0 has a unique solution. So how do you do for this? A1 by A2 is 3 by 2. B1 by B2 is k by minus 1. C1 by C2 is 0 by 0. Okay. So very clearly यहाँ पे A1 by A2 equals they have unique solution. Unique solution मतलब A1 by A2 is not equal to B1 by B2 is not equal to C1 by C2. Okay. So the questions we have done is equal to equal to equal to, but here not equal to, intersecting lines given here. So here 3 by 2 is not equal to minus k. Okay, or I can write minus k is not equal to 3 by 2, or 3k is not equal to minus 3 by 2. So something like this you can write for unique solution. Unique solution, intersecting lines not equal to. Is it clear till here? Everyone? Okay. So let me just have a quick recap, give you a quick recap of what we have done today. So in linear equations, okay, so the general form is a1x plus b1y plus c1 is 0 and a2x plus b2y plus c2 is 0. So the lines can be coincident or parallel or intersect. So when will they be coincident? If all the three ratios are equal, they are coincident. If only two ratios are on the same, I can say same line, then the lines are intersecting, coincident. Okay, and if they are this way, okay, apart from each other, they are parallel. And if two lines are intersecting at a point, they are called intersecting lines. Okay, and conditions for solvability is if all the three ratios are equal, then they are coincident lines. If only two ratios are equal, they are parallel lines. If no ratios are equal, they are intersecting lines. Is it clear till here, people? Right? Let me know, is it clear till here? Yes. So every alternate day this month, only for this month, every alternate day you will have a class of mine for half an hour. Okay, so you can join the session. So these are the questions we have done for today. And yes, not only joining the session, don't do forget to subscribe the channel so that you get the updates, you get the notification, and also hit the like button. Okay, so that you can share this to more and more people, right? So thank you so much for watching, and do comment your answer for this question. Okay, so I say k is not equal to minus 3 by 2, which means k can take all the values except minus 3 by 2. So you also do and do comment the answer of this in the comment box. Okay, and share this channel with all your friends as well so that we can have a good number. So as I told you, every alternate day you will have a math class. Okay, every alternate day it's going to be a math class. So I wish you all join on time so that you can have a wonderful session. And next session the topic surprise hai. So I'll tell you, you will know only when if you subscribe the channel you will get the notification. Okay, so thank you so much for watching people. Bye bye, take care, and don't forget to subscribe to the channel. Have a happy evening ahead.